Hi, everyone. Thanks for that bio. The emergence of affordable, versatile, and portable wireless devices has enabled a new frontier in wireless safety equipment. Existing solutions do provide personnel and asset tracking methods, but they have not been designed to optimally integrate into existing and emerging systems. Mine managers are often given the major burden of managing multiple different integration projects involving collision avoidance, person down detection, PPE management, and tracking. Ultimately, this results in a discouragement of adopting new technologies. This presentation will focus on what is required to design a versatile and multimodal mine IoT system for accident prevention and emergency management in mines. In this presentation, I will take you through why mines all over the world are placing a focus on IoT equipment as part of their mine digital revolution. We will examine what the key PPE and IoT equipment that is already being used in underground mines is today. We will look at the anatomy of a mine IoT device and all of the challenges associated in designing this key piece of technology. We will talk about how automated sign-in and inventory tracking systems enable both compliance and commitment from workers as we make their day-to-day lives much easier. We will look at how OTA, over-the-air updates, and configurations allow for customizations of IoT devices to meet the existing policies that mine managers already have. We will look at how mobile diagnostic tools are becoming essential to diagnose these IoT devices that might go missing or are found, under a seat in a tractor or in a locker. It happens quite a lot on mine sites. We will examine the key new technology of collision awareness and avoidance and the major impacts that it's going to have going forward, particularly with mine IoT. And we will look at how it's essential to design your products to integrate into enterprise tracking solutions and the collaboration required through multiple different SMEs and larger companies in this space to provide a safe solution for mines going forward. And then finally, we'll look at some real-world examples where this is currently being trialed and applied. So, Mine IoT allows for a multitude of benefits and improvements to worker safety and operation productivity. Live personnel tracking and emergency alerts with required manual acknowledgements and two-way signaling that are forwarded to a mine control room becomes possible through the use of IoT devices. Digital kiosks and tag boards allow for an automated record of equipment assignments, providing accountability to users underground. And this is a key aspect for the successful adoption and usage of enterprise tracking platforms. So, let's take a look at Huon, a soon-to-be graduate engineer working at Agnico Eagle Fosterville Gold Mine, and some of the key PPE and IoT equipment that they wear. So we're looking at things like hard hats, gloves, watches, vests, of course, a Wi-Fi and BLE-enabled cap lamp, a self-rescue kit, and an RFID and NFC-enabled ID tag. Where do these IoT devices fit in? Well, ultimately, all mine IoT personnel protective equipments, such as cap lamps, belt tags, or other wearables, become a central component in tracking, sign-in, inventory management, collision awareness and avoidance, emergency and evacuation alerts, person down detection. Most importantly, these mine IoT devices still have to maintain their core functionality. So for a cap lamp, that's something like spot and spread lighting. But all of this has to be done and achieved with extreme constraints, mainly power consumption, size, and cost. A centralized and versatile IoT platform is also required to manage, configure, update, and link all of these devices with enterprise tracking solutions. The once humble cap lamp is now a major cross-disciplinary engineering challenge. So let's have a look at this simplified exploded view of a mine IoT cap lamp. Modular mechanical, electronic, and firmware design is key for any mine IoT equipment, as seen in this diagram. Mines all over the world have already invested billions of dollars in different competing network infrastructures and vehicle collision awareness systems. For example, Bluetooth Low Energy, LTE, 5G, associative and non-associative Wi-Fi, near-field magnetic induction, and RFID can all be used for the same purpose of personnel tracking. Successful mine IoT products must be adaptable to meet the highly individualized needs of different customers, while not locking them into legacy, proprietary technology business models. Efficient space utilization and lightweight casing materials that meet IP67 standards are key to providing an IoT device that is not too heavy to fail an end-user acceptance test. When you have to wear a cap lamp on your head for 8 to 14 hours, you'll really appreciate the significance of this. Existing PPE and other non-IoT safety equipment can be tracked and assigned to miners by incorporating signing kiosks and digital tag boards into the same database system used by the tracking and emergency alert systems. Digital signing kiosks allow for immediate health checks, including assessing the battery life status of devices to ensure that they are working before they are assigned to personnel going underground. Passive RFID and NFC tags can be attached to equipment that is scanned before entry into different zones of the mine. This enables the automatic checking of PPE policy compliance, encourages user responsibility for equipment location management, and reduces the risk of device misplacement and theft. Consider the following automated sign-in process. A user takes an IoT cap lamp off a day or night shift charging dock. They then scan the interior NFC tag inside that device, and then scan their own NFC ID card. This is automatically then paired into the digital kiosk system. They then walk underneath an ultra-high frequency RFID scanner, which scans all of the non-IoT PPE equipment they're wearing, such as their self-rescue kits, their vests, and their hard hats. All of this information is then checked with a system that looks at the last maintenance dates of all of these devices. Once the user is underground, the BLE MAC address or the MAC address of their Wi-Fi cap lamp can then be used in tracking solutions to work out exactly who is in a certain place of the mine at any time. If the mine can support it, we can also then link these digital kiosks to automated turn gates. Ultimately, when the user comes out from the mine and wants to sign out, all they need to do is put their equipment back on the charging rack and it will automatically sign them out from the system, making their life a lot easier, particularly at the end of the day when they just want to go home. So, this overall Mine IoT solution can be easily integrated into a mine's existing tracking or PPE management platforms or upgraded for new integration projects through the use of over-the-air updates. So mine managers can feel assured that when they're getting these devices, future integration project with a new technology is possible because you can update the firmware on the device seamlessly. It's also a major logistic challenge to do these OTA updates sensibly. We definitely don't want a device to be updated when it's underground being used, as this would be a safety violation. So through the use of this configuration and OTA queuing system, we can ensure that devices are only going to be updated when they're not in use or will be in use for a long period of time. Particularly, for example, when you take your day shift cap lamps and you put them on the charging dock, they will then undergo their OTA and configuration cycles while the night shift ones are being used. Another major piece of technology that Mine IoT allows is the immediate live diagnostic of any IoT piece of equipment that has been found. So we've developed an Android app that allows you to take a IoT cap lamp that you might find underneath the seat of a vehicle, scan the interior NFC tag. This will automatically do a BLE pairing between your device and the cap lamp, and you can work out who it was last assigned to, its current firmware version, when it was updated, if it's safe to be currently used, any of its current health characteristics such as battery life, network configurations, etc. And then, of course, a major piece of the puzzle here is the underground tracking. So depending on the particular solution of network infrastructure that your mine has already invested hundreds of millions of dollars into, whether it be a BLE mesh, Wi-Fi, LTE, or even LoRa, using a modular design and different daughter boards, you can achieve tracking using a variety of different IoT equipment. It's very important that both enterprise solution providers and mine IoT equipment designers collaborate and use open and shared APIs so that if you need to upgrade your technology or swap to a different vendor, you can use a seamless system that doesn't require a very expensive integration project, if that's at all possible. Emergency alerts can also be called by the device user by holding down the IoT device button for a configurable number of seconds. This will prompt a device to send a message to the control room, who can then trigger a site-wide emergency. When the control room triggers a site-wide emergency, all CapLamp users will have a particular flash pattern that, again, can be configured by the control room, which lets them know that they're required to acknowledge that they've received this emergency alert, which is then sent via the chosen network, whether Wi-Fi, LTE, or LoRa, to the mine control room. Ultra-wideband and dedicated short-range chips operating on the 802.11p protocol can be used for high-accuracy collision awareness and V2X functionality. Typically, areas around vehicles are classified into multiple ranges. So the red range here is the critical range, then we have the close range and the far range, which again can be configured based on the needs of the client. Drivers and pedestrians are alerted when devices enter these ranges around vehicles through flashing lights and sounds. Automatic incidents and near-miss events can be automatically logged and forwarded to a centralized IoT database that can then be analyzed by mine managers to identify hazardous areas or drivers before an accident occurs. So let's look at some real-world examples. This mine IoT technology is currently in use and under trial at Oyu Tolgoi and Fosterville Underground Hard Rock Gold Mine. At OT Mine, we have currently deployed thousands of 5.9 gigahertz compatible cap lamps for tracking and collision awareness. RFID is used for user sign-in and sign-out. And this year, we have just started a series of new trials using dedicated short-range, Wi-Fi, and BLE-compatible lamps through a three-party collaboration with international and domestic technology partners. BLE beacons are also used and installed in safety bays in underground tunnels, where packets are then forwarded by nearby lamps to the centralized server. At Fosterville, we have collaborated with an enterprise tracking platform to enable digital sign-in and personnel localization, and we thank them for their continued support in this development. We would also like to thank Mount Isa Mines and Granny Smith Gold Mine for their continued support in developing both Wi-Fi and LTE-based IoT devices. At Goldfields Granny Smith, we are currently collaborating with private LTE networks in a joint venture for BLE and LTE-based tracking and a fully fledged digital sign-in and tag board system. As the user travels through the mine, long-life BLE beacons and their MAC address and signal strength value are forwarded to an enterprise tracking solution, which can then do personnel and asset tracking. So thank you very much for attending the presentation. I'm happy to be contacted to talk about anything mine IoT related. And cheers, I think we've got Andreas up next.